In this module, we shall study the different types of conic sections. In geometry, we come across several situations wherein two intersecting geometrical figures generate a new geometrical figure. For instance, two intersecting lines result in the formation of a point. In a similar manner, when two planes intersect, they result in the formation of a line. Now consider the intersection of a plane and a hollow sphere. We can see that the intersection leads to a circle. This intersection of a three-dimensional body and a plane is known as a cross-section. Thus, in this example, we can say that the cross-section is a circle. Let us now analyze the cross-section, which is a result of a plane intersecting a cylinder. We have seen that in the case of a sphere, the cross-section is a circle, irrespective of the orientation of the plane. However, in the case of a cylinder, we can get different shapes based on the orientation of the plane. If the plane is perpendicular to the axis, the cross-section is a circle. If the cylinder and the plane intersect at an oblique angle, the cross-section resembles an elongated circle known as an ellipse. If the plane is parallel to the axis of cylinder, the cross-section is given by a pair of straight lines. If the plane is tangent to the cylinder, a single line is produced. We now look at the different types of cross-sections which are formed when a plane intersects a double-napped right circular cone. The cross-section produced by the intersection of these figures can be a circle, parabola, ellipse, or hyperbola. Each of these sections produced is known as a conic section. Before we see how each of these sections can be obtained, let us see the construction of a double-napped cone. Let L be a fixed vertical line and M be another line intersecting line L at a fixed point V such that the angle between them is alpha. Suppose we rotate line M around line L in such a way that the angle alpha remains constant, then the figure generated is a double-napped right circular hollow cone. Though the right circular double-napped cone shown here is of a finite size, we should note that as lines L and M extend infinitely in both directions, the cone also expands infinitely in both directions. Point V is also known as the vertex, which divides the double cone into two naps. Line L is known as the axis of the cone. The rotating line M is called the generator of the cone. Angle alpha is the angle between the axis and the generator. In general, we take this angle as 45 degrees. We obtain different kinds of conic sections depending on the position of the intersecting plane with respect to the cone and the angle made by the plane with the vertical axis of the cone. Let beta be the angle made by the intersecting plane with the vertical axis of the cone. Let us look at the sections obtained when the plane cuts the nap of the cone at a region other than the vertex. We can see that the shape of the section changes as the angle changes. In terms of the nature of the sections obtained, we can say that four types of sections are obtained: circle, ellipse, parabola, and hyperbola. Click any case to understand the conditions in which the selected conic section is created. A circle is formed when the plane cuts the cone such that the plane is perpendicular to the axis of the cone. It can be seen that as long as angle beta is equal to 90 degrees, we get a circle at all positions. However, we should note that when the plane cuts the cone at the vertex at this angle, the section results in a point as shown. This is known as the degenerate case of a circle. An ellipse is formed when the plane cuts only one nap of the cone at an angle whose value is in between the generator angle and 90 degrees. It can be seen that as long as angle beta satisfies the given condition, an ellipse is formed at all positions of the plane. However, when the plane cuts the cone at the vertex for the given range of beta, the section results in a point as shown. This is known as the degenerate case of an ellipse. A parabola is formed when the plane cuts the cone such that the plane makes an angle which is equal to alpha, the generator angle. It can be seen that in the given situation, the plane is always parallel to the generator of the cone, and each time the section resembles a parabola. However, we should note that when the plane cuts the cone at the vertex, at this angle, the section results in a straight line as shown. This is known as the degenerate case of a parabola. The section formed is a hyperbola when the plane cuts both the naps of the cone at an angle whose value is greater than or equal to 0 degrees and less than the generator angle. It can be seen that as long as the angle beta satisfies the given condition, a hyperbola is formed for all positions of the plane. However, when the plane cuts the cone at the vertex for the given range of beta, the section results in a pair of straight lines as shown. This is known as the degenerate case of a hyperbola. Let us now summarize what we have learned in this module. We have seen that when a plane intersects a double-napped cone, 4 types of conic sections are formed. Further, we have seen the conditions in which each of these sections is formed.